and I may communicate with Slack if that's okay, or I can leave you alone during the recording.
Okay, sounds good. Okay, we are online. Hey guys, thank you for joining us. We are going to wait for a couple of minutes to let other people join us. Let's wait 1 more minute and then we can start. Andreas, you want to kick off?
Yes, hello, ladies and gentlemen. Thank you for joining today for our 30-minute presentation with live Q&A at the end. Please type any questions in as we go, and we will answer them after the presentation. We are recording this, and we'll send you a link after the presentation is over. And with that, I'd like to introduce Inon discussing OWASP Security Top 10 for APIs. Inon, it's all yours.
Thank you, Andreas. Hey guys, thank you so much for joining us today. This is the third part of the webinar series of OWASP API Security, Top 10 for APIs. My name is Inon Shkedy. I'm based in San Francisco, and I'm the Head of Security Research at Traceable AI. So just a quick recap. In the previous webinars, we talked about the top 10 for APIs, about the project's background, and the most critical API vulnerability, which is broken object level authorization, BOLA. In the previous webinar, in part 2, we talked about API vulnerabilities 2 to number 5. It was an interesting webinar about 4 vulnerabilities. Today, we are going to talk about the API 6 to API 10, and the next webinar series in a couple of weeks will be about how to break APIs, which is more like API security from the attacker perspective, if you're a pen tester. So basically, the agenda for today is to talk about 5 different vulnerabilities. The first one is mass assignment. Then we'll talk about security misconfiguration. injections, improper assets management, insufficient logging and monitoring. And also I have a bonus for you. I'm going to talk about something that is not part of the OWASP top 10 for APIs, but it's still a very interesting vulnerability that is very relevant for API, which is SSRF, ServerSide Request Forgery. So let's jump into the presentation and talk about mass assignment. Mass assignment is vulnerability number 6 as part of the OWASP top 10 for API list. And before I'm talking about mass assignment, it's important to understand the concept of resources and properties of resources in APIs. So let's take a look how it looks like. So, in a very high level, it's a very abstract explanation. In APIs, you have the concept of resources. And in every application, you would have different resources. So let's take a look at some type. For example, if we talk about some type of an e-commerce application, you would have the resource of orders. These are the orders that users can make in the website. And as part of this resource, you would have different properties. So, and it's important to understand that some of the properties of a resource are public and some of them are internal or private. So in the case of order, you can find the shipping address, and which is a public property, because if you think about it, when you make an order on Amazon, you should have the ability to edit or to change the shipping address. So I would consider it as a public property. But if we talk about the total price property of the order resource, this is something private, because as a user, you shouldn't have direct access to edit this internal property of total price. The same thing about the user resource. You can find a first name and last name. Those are public properties because you should have access to edit your first name and last name. But on the other hand, the role or the group of the user, this is a private property because you shouldn't have direct access to edit your current role. You shouldn't have access to change yourself from a guest to an admin. Those are things that they're like other processes behind the scenes that should allow other users to edit these properties, but not you as a user. So mass assignment, like in a high level, allows you to edit internal properties of resources that you shouldn't have access to them by design. And it's a bit technical vulnerability, and many people don't find it very intuitive to understand. So let's try to understand step by step how developers write code that is vulnerable to mass assignment and allows you as an attacker to edit internal properties that you shouldn't have access to. And then we'll try to understand the impact of it. So before I even talk about mass assignment and how is it possible to edit internal properties, let's talk about what is not mass assignment. How can you write a secure code which is not vulnerable to mass assignment? So in this case, we're talking about a client that wants to create a new user. This is just a regular registration process. So the client would send an HTTP call to create user and would pass first name, last name, and password. And then the application server, the code would look something like that. You could see that the developer would fetch each one of the parameters separately and assign each one of the parameters to a new variable in the code itself. So you would take the request query and assign to the first name parameter, and you would do the same thing for each one of the properties. So this code is not vulnerable to mass assignment because the developer actually choose specific parameters to assign to the properties. And then the developer makes sure that there is no option to edit properties that, that are internal. So this code is secure. But if you think about it, if you take a look at the code, it consumes a lot of time because you need to parse each one of the parameters separately. What happens today is a bit differently. You can see many modern environments, especially if we talk about frameworks like Node.js and Django and Ruby on Rails. These frameworks encourage developers to use something that's called mass assignment. Mass assignment is not an exploit by design. This is more like a feature that allows developers to save a bunch of time by, instead of like parsing each one of the parameters separately, they can just take a whole object from the user, from the client itself. This is an example for a JSON object, and to save and to take this JSON object as is and to store it as a new record on the database. It's basically one-liner. You just take the JSON string and convert it to a new object to a new record in the database. It saves you a bunch of time. It's very convenient, and it's like some black magic of the ORM environment. But it also opens the door to mass assignment. Why? Because there is no validation that these properties are not internal. So let's see how an exploit would look like to this specific scenario. So here we can see a legit API call to the create new user API endpoint. You just send the username and password in order to create a new user. But then a malicious API call would contain only additional parameter of role equals admin. And because the developers use the mass assignment functionality in the backend, they would just take this whole object and store it in the new record in the database using this special ORM function. And this is where you can assign to yourself a role of an admin and to perform some type of privilege escalation. There are many ways to exploit mass assignment. This is just one example. If we talk about a resource of an order, you might be able to edit the total price of the order if it's vulnerable to mass assignment. So some of you might be familiar with mass assignment, but the thing is, mass assignment is not something new. It's been around for a while, but it's much easier to exploit mass assignment in APIs. In order to understand why, we need to understand the nature of mass assignment. If you compare mass assignments to vulnerabilities like SQL injection or cross-site scripting, it looks a bit different. The reason is that there is no one straightforward way to exploit mass assignment. You can't really use automatic scanners to exploit mass assignment because you need to understand the business logic of the application. And basically you need to understand what are the internal properties and how you can change them to cause something malicious. So if you have this API endpoint of put/v1/videos/video ID, and if you just click on buttons on the UI, and you try to edit the name of the video, you see an API call to this API endpoint, which with only one parameter of name. The name of the video is a public property. But even if you knew that this endpoint is vulnerable to mass assignment, it would be challenging for you as a pen tester to know what properties you could edit that would cause something malicious. You basically need to understand what are the private properties of this resource of video. Fortunately, in APIs, it's much easier. Why? Because the REST standard encourages developers to expose the structure of the resource. You just need to find another get API endpoint that returns you all the properties of this video file. So in this case, we can see the get/v1/user/video file, and you can see all the internal and all the internal and public properties of this video resource, including the name. But then if you take a look here, you can see also that there is a property of conversion parameters, which is an internal property that you shouldn't have access to. But because we know that this endpoint is vulnerable to mass assignment, you can edit this property. And also the second hint that we get here from this API response is that if you take a look here on the payload, and by the way, this is based on a real example. This is something that I found in some banking application. You can see that the payload looks like something that will be concatenated to a shell command. And this is where you can create a mass assignment payload to assign to yourself this internal property of conversion parameters of the video resource, and to concatenate another shell command to format drive C. So this is just one example how you can exploit mass assignment and how you can leverage the predictable nature of REST APIs in order to understand what are the internal properties of this object. Just a recent example from New Relic. This was found by the security researcher James Kedel from Port Swigger. He managed to create himself, he managed to gain himself free API access to New Relic. This API access, it's something that you should pay for. It's something expensive that New Relic offers, but because he found this endpoint of account/account ID, he managed to change the flag of allow API access, which is an internal property, by exploiting mass assignment. Okay, so let's jump into API number 7, security misconfiguration. This is basically a bucket of bad things: hard-coded passwords, weak encryption keys, unnecessary exposed HTTP methods. These things usually can be found using automatic scanners. So I would encourage you to use automatic scanners to find this type of vulnerabilities. For example, you can find many of them using a burp suite. The next vulnerability is number 8, injection. So you probably all know about injections in general, and there are different types of injections. But you know, injections have been around for a while. And if you take a look at the previous OWASP top 10 lists, you can see that injections have been always number 1 or number 2 as part of this list. And we decided to move it from number 1 to number 8 when we created the list. Many people ask me how you can do it, how you can just decide that injections are not super relevant anymore, that you just move them from number 1 to number 8. So this is a great question. And I want to talk a little bit about the nature of injections, because injections, it's more like a general term. It contains a few different families of injections, right? So the most common types of injections, it's SQL injection, and then shell injection, and expat and LDAP injections. So the reality is that in modern applications, in APIs, those types of injections become much less common. It's not very common to find SQL injection and shell injections today. Let's try to understand why. If we talk about SQL injection, many of them are solved by design just because developers use ORM environments. And I'll tell you a secret, the reason why developers use ORM environments, it's not because of security, just because it's more convenient. And the learning curve for this environment, it's much faster. And the second point, there are so many security projects to solve SQL injections. So security projects and security products to solve SQL injections together with the proper developer education led to a situation where SQL injection become less common. If we talk about shell injections, so the reason why, one of the reasons why traditional applications like 5 or 10 years ago used to be vulnerable to shell injections, which is a scenario where part of your input as a user would be concatenated or joined to a string that will be run as a bash command or just a shell command. So the reason why it used to be common, it's because developers used like hacks, basically they didn't find the right library that they can integrate with. So many times they would just run a local tool to achieve the same goal. But because we have more open source libraries today, they can replace the shell. These shell hacks used to be performed by developers. And also today, code that is, if we use like internal CMD tools as part of our code, this is usually what developers do when they write code that is vulnerable to shell injection. It's not very scalable in the microservices world. So you can see less and less shell injections today. And if we talk about XPath and LDAP injections, these technologies are not, they're not really in use today in modern applications. With that being said, you can still find today NoSQL injection, which is kind of the new type of injections for modern applications. In this example, you can see how we can bypass an authentication mechanism that is based on NoSQL technology in order to log in as admin. So NoSQL injection are still a thing, but they are usually less common and also less severe. The reason why NoSQL injections are less severe than SQL injections is because those NoSQL databases and environments like, for example, MongoDB, those modern NoSQL environments, they were written with security in mind. For example, if we take a look at Oracle, which is a SQL database, you can see that it has thousands of functions built in that can help an attacker to leverage a SQL injection. For example, you might have a function in Oracle to write a file to the file system. So when people planned those like more traditional SQL databases, they didn't really think about security. If we talk about NoSQL databases, they are more modern and they were designed and written with security in mind. And this is why it would be harder for you to, usually it would be harder for you to exploit NoSQL injection. Let's jump into API number 9, improper assets management. So this is some type of like housekeeping vulnerability. It's not super exciting, but it's very important to implement it. So there are two subcategories to this vulnerability. The first one is undocumented API endpoints. This one is pretty simple. This is the responsibility of the developers. So if you have an API host that hosts 3 different endpoints, the first one is get users, object location, and export all users. So the first 2 are documented. They're part of the Open API or the Swagger file. But the thing about the third one, about the export all users endpoint, is that this endpoint was developed like a while ago by a developer like 2 or 3 years ago. And this developer was focused on delivering, not documenting. So he forgot to document this endpoint. And basically, it causes a situation that nobody knows about the existence of this entry point to the API. And this is very dangerous because like from the attacker perspective, each new endpoint or every endpoint that you have on your API is a potential place to attack. And you need to have a full list of all the entry points to your application. And it becomes much more challenging to document all the endpoints when it comes to modern applications, just because, you know, CI/CD and Agile and the nature of these environments that encourage developers to change APIs all the time. The second type, the second family of under this vulnerability is undocumented API hosts and microservices. So if you're hosting your application in the cloud, you can see that you have 3 different API hosts, the payment API, the mobile API, that both of them, there is some documentation, people understand what is the purpose. This is for the payment API, this is from the mobile API. But then in many companies, you can find those type of shadow APIs like QA-3-all. In many companies that I perform pen tests to, I went to the DevOps team. I asked them, hey, what is this weird environment like this QA-3-all? And they would tell me something like, we don't really know, but we are afraid to remove it. This is something that like some engineer created, but he left the company, and we are kind of afraid to remove it. So if you have this type of environments, of this type of microservices that nobody knows what is their purpose, and they're just there because all the other people are afraid to remove it, this is also usually a bad thing, because many times these old environments would contain more vulnerabilities, and they would be a much more interesting target for attackers if you compare them to the well-known APIs and microservices. And this is what we call shadow APIs. API number 10, insufficient logging and monitoring. This is probably not the sexiest vulnerability, but it's also very important. What happens today, you can see in many companies that got breached, because they don't have good logging and monitoring, they don't really know what got impacted. It's very important that if a breach happened, and breaches happen all the time, you can't be 100% protect. You need to have decent logging and monitoring so you can trace back the attacker and to understand what resources, what data the attacker has been accessing during the attack. And so this is the last vulnerability I want to talk about today. This is SSRF, Server-Side Request Forgery. It's a very common vulnerability in APIs. I can find it in almost every API that I test. It's a pretty interesting vulnerability. So in order to understand what happens when you find an SSRF vulnerability, I want to give you an example for a feature from like, let's say this is some type of social media website or something like that, and you have an option to update your profile picture. And there are two options. You can upload a local file from your computer or a phone, or if you have like a slow Wi-Fi connection, the website allows you also to upload the image or the file from a URL. So you just paste the URL and click done. This is very convenient, right? But have you ever happened to think what happens behind the scenes when you upload a file from a different location, which is not your personal computer? So let's see what happens. Your client would send an API call to update profile picture endpoint, which is the URL that you want to access, basically the URL of the picture. And then the API would actively send an HTTP call to download this picture from picture.com. So if you think about it, if you edit this URL here of picture.com, you can also put a malicious URL of a malicious file. And when it comes to SSRF, there are so many ways to exploit it. Like one example, if I change this URL to a URL of a file that is very large, like let's say a file of 5 or 10 gigabytes, and then I repeat this API endpoint 100 times, I might cause layer 7 denial of service, because I would cause the API send a bunch of HTTP calls to download large files, and the servers would be too busy to handle these files, and it could cause denial of service. This is just one example. A few other examples, you can perform internal port scanning using this technique. For example, if you want to see if internal ports are open on the machine, you could send, like, if this is the URL, let's say this is the api.com, this upload picture. So the URL, you could put in the URL something like that. Like this is a local host, and then to try to access port number 22 and to see if SSH is open on the local machine. Because if you get an error, it means that the URL is not accessible. And if you get 200 OK, it means that the port is open. And then you can just keep scanning different ports locally on the machine or locally in the environment. Sometimes you can access internal APIs. So let's say that you have some intelligence, you have some information about this environment, and you know there is like internal API under this this URL to delete all the users. This endpoint is accessed only from the internal environment, but because you have access, because you can make the internal servers make an external request, you can basically change the URL to this API of the little users and to trigger an internal function. There's not much to talk about SSRF. This is a very interesting vulnerability, and there are many ways to exploit it. This is just the tip of the iceberg. If you want to get more information, I encourage you to go to this link. This is a very good resource by Vicky Lee about SSRF. Yeah, so this was the OWASP top 10 for API list. We covered all of them in the last 3 webinars, and we also talked about SSRF. And now is the time for questions.
Thank you, Inon. That was a very interesting and informative presentation. Ladies and gentlemen, you have the opportunity to ask Inon your questions about the OWASP top 10 and API security. Please type them into the chat box and we'll start going through the list. And one note, we have recorded this and we'll send you a link to this recording. And we'll also send you links for episodes 1 and 2 so you have the whole series together. And of course, we welcome you to share this series with your teammates at your organizations. So let's wait for a moment for people to type in their questions. Okay. Inon, here's one for you. Why did you split the authorization vulnerabilities into 2 categories, object and function level, instead of having only one?
Yeah, this is a great question. Many people asked me this question in the past, because if you take a look at the OWASP top 10, the previous list, you could see it's the same category of just authorization bypass vulnerability. The reason why we decided to split this category into two different categories for broken object level authorization and function level authorization, it's for the same reason why you could see that SQL injection, that if you take a look at the previous list, you can see that injections and cross-site scripting are under different categories. Because if you think about that, cross-site scripting, it's also some type of injection. You could just call it script injection. But the reason why these categories have been splitted, it's because like injections and cross-site scripting are so severe, they deserve their place of honor. They deserve like two different categories. And it's the same thing about broken object level authorization and broken function level authorization. The fact is that the BOLA vulnerability, number one, is so severe and so critical. And this is by far the most critical vulnerability in APIs. If I could, I would just put BOLA as number one and number two. It deserves its own place. And also broken function level authorization deserves its own place. Any other questions?
Okay, thank you. Yes. We have another couple questions. How does one protect against these? Is there a WAF?
Yeah, it's a good question. You know, there are some application firewalls that can protect against some types of some of the OWASP top 10 for APIs, especially if we talk about injections and the more traditional vulnerabilities. But when it comes to more like authorization problems, and when it comes to things like mass assignment, web application firewalls usually fail protecting against this type of vulnerabilities. And the reason for that is that the way that usually web application firewalls work is using signatures. And you can't really write a signature to protect against BOLA, because if you think about broken function level authorization, broken object level authorization, you just change the ID from like 6 to 5. And this is not something that the WAF can tell you, hey, this user shouldn't have access to this object. They're not built to perform this type of analysis. And if you want to protect against the OWASP top 10 list, I would encourage you to check Traceable, which is the product that we are working on. This product is designed to solve the OWASP top 10 for APIs. And basically, our product performs some machine learning and more sophisticated analysis on the payloads to understand the baseline, and from that to understand the business logic and to detect the OWASP top 10 for API.
Okay, one more here for you, Inon. We have a question about open redirection to SSRF, and if a local host is directly not accessible.
Open redirection to SSRF. Yeah, the open redirection, it's a vulnerability that you can use, like if you have some local hosts that are not accessible from the SSRF because of some partial protection, sometimes you can leverage open redirection to bypass this protection. But open redirection and SSRF is usually different vulnerability. You can definitely chain them together to bypass some SSRF protection mechanisms. I see another question, how you can protect against SSRF on the Q&A section. This is a great question. It really depends on what the application is supposed to do. If so the best idea to have is to allow the user entering a URL of only a few different endpoints. Basically, to say, if the user enters a URL that the API is going to access, to basically to have a whitelist of URLs that the user is allowed to enter. But many times it will break the functionality, and you want the user the ability to access every URL over the internet. And this is pretty tricky because there is no one bulletproof mechanism to protect against this type of vulnerability. If you allow the user, if you allow your client to enter a URL and then you access this URL from the API, there is always a place to exploit something. It can be denial of service, it can be internal post scanning, but there is some cheat sheet that talks about how to implement a good mechanism to access external resources. I can send it to you. In general, I would recommend you to have a proxy that not to access this URL directly from your API that runs the business logic, but to access it through a proxy. And if the proxy is down, or if the proxy is exploited, it wouldn't impact your API, like to have another layer in between.
Okay, there's one more here for you. Okay. Ladies and gentlemen, if you have any other questions, please go ahead and enter them in. Otherwise, we'll wrap up for the day. Okay.
Cool. Thank you so much, guys.
Thank you very much, Inon. Very interesting and informative presentation. Audience, look for the recording sent to your inbox soon. If you have any, If you have any questions, please visit traceable.ai for more information, or we can give you a product demo and answer questions specific to your environment in a meeting. Okay. Have a wonderful day. Bye-bye.
Bye-bye.